People, my people, this is where second semester I told you becomes a little bit technical. A little bit what? Technical. You see, they gave us Q1, they gave us Q2. They said, according to the diagram, they are separated by a distance of 5 meters apart. Okay, notice something. The charges you have here, they are on a single line that is not standing vertically, not standing horizontally. That means that this line here is inclined. Now, once you have charges located in a single straight line that is inclined, or in more than one straight lines, let's say I have something like this. I put a charge here, call it Q1. Put another charge here, call it Q2. And I ask you to get the force on 1 due to 2. This is coordinate system. Do you understand? All right. Now, we talk about charges in coordinate system when, number one, the charges are located, yes, in a single straight line, but that line is inclined. Or the charges are located in more than one straight line, like you see here now. Now, my people, once, Coulomb's law, you did Coulomb's law when you were in secondary school, when you were preparing for WAEC and JAM. If you have a charge, or if you have two charges like this is Q1 and this is Q2, and they are separated by a distance of R apart. Now, this one is very simple. That's that one you did when you were preparing for JAM exam. The charges are located, yes, on a single straight line, but the line is perfectly horizontal. What you're going to do here is the same thing you're going to do when the charges are located on a single straight line that is vertically oriented. Just tell them that the force is defined as K, Q1, Q2 all over R squared. That's all. That's what you're supposed to do. However, if you have a coordinate system where the charges are located either on a single inclined straight line or on more than one straight line coordinate system, the new formula becomes like what I have here now. They say find the force on 2 due to 1, which means I'm looking for the force that 1 is going to exert on 2. Now, see the way we write the new formula. The force on 2 due to 1 will be defined as K Q1 Q2 over R squared. This R is the scalar distance existing between the two of them, which in this diagram is 5. Then times what we call R cap. R cap. This R here is a unit vector pointing from 1 to 2. Remember that the question says find the force on 2 due to 1. That means you're going to 2 from 1. That is what this R will represent. A unit vector pointing from 1 to 2. When the force you're looking for is force on 2 due to 1, the unit vector here will be pointing from 1 to 2. If it is force on 1 due to 2, 1, force on 1 due to 2, the unit vector will be pointing from where? 2 to 1. Alright, now let's do this together. How do you get this unit vector? How do you get it? Very simple. The unit vector is the vector itself divided by the magnitude of that vector. I hope you still remember. The vector itself divided by the magnitude of that vector. That's unit vector. So, if I want to get the force on 2 now due to 1, looking at what I have here for coordinate system, the only thing new here, that's why I told you that second semester is technical. Everything becomes new. That's why university starts, as a matter of fact. That's why when I talk about you joining this program right now, if you're targeting first class, you want to make yourself happy, proud, make your parents proud, make your generation proud, it starts with something like this. Come on board. We're running a promo. 5K covers everything you're going to learn from the bookish for the entire semester. For now, that's online. The physical remains 10K for all the courses for the entire semester. Now that we are running promo. Talk to your parents. Some of you have already traveled. You may be sitting with your daddy, mommy now, And we're talking about online class. The primary reason you're here. Talk to them. I'm sure there's no daddy, no mommy that will say, I will not give you 5K to be part of this program for the entire semester. They will. I trust them. You have good mommies and good daddies. Now, return home. I want to calculate the force on 2 due to 1. Let's substitute into this formula. Let's see what we are going to do. Pay special attention, especially when I come to this unit vector. Pay attention. Now, this is going to be, K is a constant, 9 times 10 raised to power 9. Q1, thank God it's already given in coulomb. If this thing we are to be given a micro coulomb, you need to multiply by 10 raised per minus 6 to convert it from micro coulomb to coulomb. But luckily it's already in coulomb, so I'll just multiply by 3. Q2 is 4 coulomb over scalar distance between them, which is 5 raised to the power of 2. Times, this way I need you to pay special attention. This R cap, remember I said it's a unit vector pointing from 1 to 2. It means that we are going from, pointing from where? Pointing from 1 to 2. That means that we are going to 2 from 1. The rule says, do not move along the ladder. Do not. Movement along the ladder for coordinate system analysis of charges. The movement along the ladder is highly prohibited. Do not move along the ladder, even though you're going to 2 from 1. Because they say force on 2. That means you want to exert the force on 2 from 1 now. So you're moving from 1 to 2. But do not move along the ladder. Move in a coordinate system. First, you move horizontally like this. You cover a displacement of. Did they give us this value? Okay, I think they didn't. Okay. This place is supposed to be 3. This is supposed to be 6. This place is 4. And this place is 8. Okay? So, if I move from here to here, I have covered the displacement of from 3 to 6. That is 3 meters. And I'm moving towards the positive x direction. So I'm going to put I. Remember what we did in the first semester. I is a unit vector pointing along the positive x-axis. Assuming I'm moving the other way, it should be minus 3i. The I will carry minus. But because I'm moving towards the positive x-axis, that's why I'm putting I. It means I cover the displacement of 3 meters along the positive x-axis. No wonder we have this I. Remember, we are going to 2 from 1. And you don't move along the ladder. You move in a coordinate system. First, you move horizontally, then you move vertically. You have still gotten to 2 without moving along the ladder. Now, if I move horizontally, I will cover a displacement of 3 in the positive x direction. That's why I have I. Now, let me move this. This is 4 coulombs. Remember? I will now move up from here to here. That is moving from 4 to 8, which is a displacement of 4 along the positive y-axis. So that is j. So it means that the vector moving from 1 to 2 is 3i plus 4j. That is 3i plus 4j. That's the vector over the magnitude of that vector. How do you get magnitude of a vector? It will be square root of coefficient of I square plus coefficient of j square. Are we together, somebody? So if you evaluate this now, it's very simple. Use your calculator. If you punch this out, you evaluate what is in this bracket. Open the bracket, multiply everything inside the bracket with what you have outside. You have gotten the force on 2 due to 1. Remember, your answer will still be in IJK form. Except if they say look for the magnitude of the force. If they say look for the magnitude of the force, if they do something like this, that means after getting this expression in the form of IJK, you now look for the magnitude. Of course, you know how to do that now. You take square root, then inside the square root, you say coefficient of I square plus coefficient of j square plus coefficient of k square, as the case may be if there is k involved. Does that make sense? That's what we do in analysis of charges in coordinate system. I will see you shortly. My name is Bookish.